mathematics. How much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
Good morning, grade 12s. Today is Thursday, April the 16th, and we're covering the last topic in our unit on conservation of energy and momentum. And before we get started today, though, I do want to encourage you with a verse of the day today once again. And so today's verse of the day comes from Galatians chapter 2, verse 20, where it says, I have been crucified with Christ, and I no longer live, but Christ lives in me. The life I now live in the body, I live by faith in the Son of God, who loved me and gave himself for me. So I want to focus on the last part of that. The life I now live, I live in faith in the Son of God, who loved me and gave himself for me. And so I want to encourage you today to live by faith in the Son of God, who loved you and who loves me and who gave himself for us. And so we have that faith, we have that hope, we have the assurance that he loves us, and we want to live in such a way that that faith is shown. So I encourage you as you go throughout your day today that you would do that. All right, getting to today's lesson. So today what we're doing is we are solving elastic collisions. And so again, an elastic collision is a collision between two objects where energy and momentum are conserved. When we have inelastic collisions, again, you did some reading on this, inelastic collisions is where the mechanical energy is not necessarily conserved because we are losing energy to heat or light or some other form of energy that is not quantifiable with mechanics equations. And so what we have here in this question that I'm going to do behind me in a moment is we have two objects that are approaching one another, or not. We have two objects, and they have a combined energy, and they have a combined momentum, and they're going to collide in some fashion. And so their energy before and their energy after have to be equal. And same thing for momentum. We did some momentum questions previously too, where we had two objects approaching, colliding, and they had momentum before and momentum after. What we're going to focus on today, though, is in all of our questions that we did with momentum previously, we had the velocities of the two objects initially, and we had the velocities of one of the objects afterwards, right? That's not always known, right? Often we'll know the velocities of the objects before the collision, and we can get the total energy or total momentum before the collision. But afterwards, we don't have any information on either of the objects, what they're doing after the collision. We know their masses, but we don't know their velocities. So the formulas that we're going to walk through on the board behind me deal with what are the final velocities after the collision for both objects. All right. And I'm going to go over it on the board behind me. I've got the formulas written there. We'll walk through it step by step, but it's not full and complete. Okay, so I wanted to go over it in a summary, and you can see there's a little blue box behind me where we're going to have our formulas. And I'm going to put a handout on Connect that explains it a little fuller. Guys, didn't have room on one board, and I didn't want to go to two boards. And then I've got an example on the other board that we'll go through as well. And then you're going to get 3 questions on it, and they're all sort of similar. So, when we look at the board behind me, okay, previously we know that in a collision, any collision, momentum is conserved. So I've simply got P total equals P total prime. All right, and our formulas again then are M1 V1 plus M2 V2. Again, that's object 1, object 2. And here we have M1 V1 prime and M2 V2 prime. So this is our conservation of momentum formula that we've seen before, and you've done problems with it. It was on your last test, and you all did well on that. Okay. We also know from the work we've just been doing that energy is conserved as well. So the E total before has to equal E total prime, which is the after energy. And that's why I put in my kinetic energy formulas now, because they're moving objects. Right? We're going to have 1/2 mv1 squared, 1/2 m2 v2 squared. Again, object 1, object 2. And then same thing on the other side with the primes for after the collision. Okay, now here, what we're going to do, though, to make the math a little simpler, here's our situation. Before, we have m1 moving to the right with a velocity, and m2 is stationary, okay? And that gives us this formula here. m1, v1 prime, okay, so object 1 with its mass and velocity, kinetic energy, plus 0, okay? So object 2 is not moving, so its kinetic energy is 0, and then on the right-hand side we have our after. Okay, same thing with momentum. We have our momentum of object 1, the initial momentum of object 2, and then the after momentums. And again, momentum has to be conserved. And that's our after one here, right? We have M1 moving, we have M2 moving. Again, we don't know the directions, so this is just for this particular setup here. They could be moving in opposite directions, we don't know that. Now, with these two formulas, I've labeled them Formula 1 and Formula 2. On the handout that I'm going to give you, you'll see that we're going to take these two formulas and we're going to simplify them a little bit and rearrange them a little bit, and then substitute one into the other. And when we do that, and again, it's on the handout, hopefully you can read the handout that I'll give you and make sense of it, but it is simply rearranging and substituting. Out pops these formulas, all right? And these are formulas for velocities after the collision for both object 1 and for object 2. Okay, and again, when you look at the handout, you'll be able to see how we simplified and substituted to get these two formulas. And these are the two formulas that will allow us to solve for the after velocities, knowing, all we need to know is V1 for the objects. All right, now, we said in this that mass 2, M2, was stationary. It's not always the case. So in the example we're going to do over there, we're going to have an example where both objects are moving, but we're still going to use these formulas. It just requires a slight adjustment in the point of reference that we're looking at this question from, and then we'll be able to again solve questions that ask us to find the final velocities after collision where we don't know either final velocity. All right, let's move on over to the other board. I've got the example there. We'll walk through it. Hopefully it will make sense. And again, yeah, let's go do it. All right, here's our example. So in this example, we have a 4 kilogram mass moving to the right, 5 meters per second. We have a 2 kilogram mass moving to the left at 4 meters per second. And the question simply says, find the velocity of each object after they collide. So, because this is moving at 4 meters per second, the formulas that we just had on the other board don't necessarily apply, because in those, to get those formulas, we took M2 to have a velocity of 0. Here we clearly don't have a velocity of 0. But if we go from the point of reference of M2, all right, so if you're M2 and you're looking at M1 approaching you, right? If you're approaching M1, kind of like driving on a highway and having cars approach one another, right? From your point of reference, you can say you're at rest and the other car is approaching at the sum of your speeds, two individual speeds. So from the point of reference of M2 here, M1 is approaching it at 9 kilometers per hour, right? 5 plus 4. So that's what we want to do. We want to say, okay, if I say I'm on M2 and I'm at rest, M1 is approaching me at 9 meters per second. Okay? So it's just a matter of looking at it from the point of reference of one of the particular objects. Okay, and then that one becomes 0, because if I'm in a car traveling to the left at 4 meters per second, and I have something approaching me at 5 meters per second, if I assume I'm at rest, if I pretend that I'm at rest, from my point of reference, I am at rest with the car, and that other object is approaching me at the sum of our speeds. So 9 meters per second and 0 meters per second. Once we do that, we can now use the formulas. All right, so now I can plug in my formulas. I have an M1 prime, formula written out here, filled in the formula, and I get 3 meters per second. Do the same thing for V2 prime, formula, fill in the formula, get 12 meters per second. Now, what we have to remember is those are the velocities from the point of reference of M2, okay? They're not the actual final velocities, just like 9 and 0 weren't the actual velocities of the objects, 5 and 4 were. here we have again 3 and 12 from the reference point of M2. So to get this 9 and 0, we added 4 to both these numbers. So when we get to the end here, to reverse that, we have to subtract 4 from both of them. And if we do that, we get V1 prime equaling -1 meters per second. The negative simply means that it's moving to the left. And we get V2 prime equaling 8 meters per second, which means it's continuing to go to the right. So what's happening is these two objects are coming together, they're colliding, and then they're going apart again in opposite directions. Right? This left one, this V1 prime, was moving to the left slowly at 1 meter per second, while this V2 prime rebounded off that way to the right at 8 meters per second. And the key to these questions is being able to make V2 equal to 0 by taking that object 2 as your reference point, making it equal to 0, getting the answers, and then remembering to reverse that, whatever it is. Okay? If it's equal to 0, great, just use the formulas. If it's not equal to 0, then we have to do this. Okay? I'm going to give you 3 questions. They're going to be on a handout as well. And try the 3 questions. They're exactly like this, and hopefully it'll make sense. And that will bring us to the end of this unit. So for tomorrow, for Friday's lesson, I'll go over the 3 questions, or a couple of them, and then I'll put a test online tomorrow as well, on Friday, and I'll give you until the following week, Friday, to hand in that test. It will be, I mean, you can use whatever resources you want. I'm not there to watch you, so I'm assuming that you will use resources and that you will be able to, it'll be like an open book test. And so you'll have your formulas and you'll have whatever resources you have to do the questions. And hopefully you will just do them on your own, that you won't be using PhotoMath or anything of those apps that do the questions for you, but you'll just be able to do them using the resources that you have available to you that don't actually do the question for you. So do the 3 questions. Hopefully it goes well. If you have any questions that you'd specifically like me to answer, please email me their questions and we'll go from there. Hope you have a great day, and we'll see you tomorrow.